when you're studying the binomial theorem, then you should be familiar with the Pascal's triangle. That is 1 here, then you have 1, 1. Then you have 1, the sum of these two ones is 2, and then you have 1 here. Then you have 1, 1 plus 2 is 3, this is 3, and this is 1, okay? Then you have 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then you have 1 here. This is called the Pascal's triangle, okay? You have 1, then you have 5 here, then you have 10 here, then you have 10, and then you have this 5. And then you can keep on, like, writing down this. This is the Pascal's triangle. Now, why is it important to know about the Pascal's triangle while doing this binomial theorem? Is because binomial is basically, that is a polynomial with just two terms, and typically this is going to be a plus b. Okay, when you have a plus b raised to power 0, like when you have a plus b raised to power 0, you have this equal to 1. Anything raised for 0, that is going to be 1. Now, when you have a plus b raised to power 1, so that is equal to a plus b. Okay? And then let me expand here, the a plus b whole square. That is a squared plus 2ab plus b squared. So this is a plus b whole square. I'm writing it here. This is a squared plus 2ab plus b squared. And if I expand a plus b whole cube, now you must be wondering that what is happening here. Now this is a cube plus 3a square b plus 3ab squared, and then plus b cube. So I'm writing it here, this a plus b whole cube. That is a cube plus 3a square b plus 3ab squared plus b cube. Now, before I go onto the a plus b raised to power 4, I want you people to notice that what is the relationship of all these expansions here with this Pascal's triangle. Now, look at this. This is this. If there is 1, so you have just 1 over here, okay? Now, this 1, 1 is basically, this is referring to the coefficients of these terms. This is 1a and this is 1b over here, okay? So you have this 1 and this 1 over here. Similarly, if you look at this a square plus 2ab plus b square, this is quite interesting. You see this coefficient is 1 here, this is 2 over here, and there is a 1 over here, okay? This is 1, 2, 1. Okay, I'm just going to pause this for a minute. So I was here, like a plus b whole cube. Now, again, you look at the coefficients of these terms here. So you have here, for example, if you see that you have 1 here, you have 3, 3, and then 1. So this is 1, 3, 3, 1. Now looking at this pattern, you can tell that what is the expansion for this a plus b to the power 4 without even using that binomial expansion. Just look at this, it is a, b. Now look at this a square. What is happening to the powers on a square, then a, and then there is no a. And look at the powers on b. There is no b over here, then b raised to power 1, and then b squared. Similarly for this a cube. This is a cube, a squared, a, and there is no a. Now, in the same way, I'll be using these as the coefficients, and I'll have, first of all, this as a raised to power 4. Then I'll have 4a cube b plus 6a squared b squared plus 4ab cube, and then plus b raised to power 4. This is really cool, okay? Now look at this. I'll be expanding this a plus b to the power 5 without any formula. So this will be a raised to power 5 plus 5 a raised to power 4 b plus 10 a cube b squared plus 10 a squared b cube plus 5 a b raised to power 4 and then plus b raised to power 5. So if you're familiar with this now, with this Pascal's triangle, then you can easily understand this binomial expansion. Now, if you don't want to use this, then there is basically a formula which is a plus b raised to power n. Now this is nc0, a raised to power n, and b raised to power 0. And then you have nc1, a raised, now the powers on a will be decreasing and the powers on b will start increasing, plus nc2, this is a raised to power n minus 2 b squared, plus nc3, a raised to power n minus 3, there is b cube, and so on. Finally, you have ncn, a raised to power 0, and then there is b raised to power n. Now let me expand this. A plus b raised to power 5 using this formula. A plus b raised to power 5. So now this n is going to be your 5 now, okay? This is 5c0, a raised to power 5 and b raised to power 0. Then you have 5c1, a raised to power 4, and this is b raised to power 1. Then you have 5c2, a raised to power 3, and then there is b squared. Then you have 5c3, that is going to be a squared and b cubed. Then you have 5c4, there is a raised to power 1 and b raised to power 4. And finally, this is 5c5, this is a raised to power 0 and b raised to power 5. Okay? Now, if you recall, you have just finished that permutation combination. You must know that nc0 or 5c0, that is 1. So this nc0 is always 1. ncn, that is 1. So 5c5, that is going to be 1. So this is really interesting. Now, many students that they ask that what does this NCR have to do with this binomial expansion? So this is so interesting, though so amazing to see that, like if you expand this, for example, if you expand this a plus b whole square using the binomial expansion, look at this, what will you get? A plus b whole square will be 2c0, a raised to power 2 and b raised to power 0. Then you have 2c1, a raised to power 1 and b raised to power 1. And then you have 2c2, a raised to power 0, and this is b squared. Now your 2c0 is 1, and this is going to be a squared. 2c1 is 2, and this is ab, and this is going to be b squared. So this this 1 over here is basically 2c0. This 2 over here is 2c1. And this 1 here is representing 2c2. Similarly, over here for this 1331, this 1 is representing 3c0. This is 3c1. This is 3c2. And this one is 3c3. And similarly for this last one, let me change this color here. Uh, this is going to be 5c0. This is 5c1. This is 5c2. This is 5c3. This is 5c4. And this is 5c5. If you use your calculators, you will see that 5c0 is 1, 5c1 is 5, 5c2 is 10, 5c3 is 10, 5c4 is 5, and 5c5 is 1. So that is why you have this nc0 here. When the power is n, you have nc0. The next term will have nc1. This has nc2. this has NC3, and the last term has NCN in it, okay? And similarly, if you look at the powers on n, look at this, there is a power n. This power is decreasing. This is n minus 1, n minus 2, n minus 3. And finally, this is becoming 0. And then you look at the powers on this, this b. These powers, they're increasing. Look at this. This is 0 here. This is 1 here. This is 2 here. This is 3 here. And this one is n. So these powers, they are going upwards. So the same was happening in all these expansions over here, even in this case, even in this case, here and here, okay? So you need to remember this formula for the expansions of these binomials here, okay? So we are